This video is meant for Mrs. Rose's AP Calculus class, and in it we're going to talk about the third free response question from our Limits AP Packet. Okay. Use the definition to show that this f of x function is continuous at x equals 4, where the piecewise function is split. The definition of continuity is you need to show that first the limit exists at x equals 4 of f of x, second that f of 4 exists, and third that the limit as x approaches 4 of f of x equals f of 4. In order to show number 1, you have to show that the limit as x approaches 4 from the left equals the limit as x approaches 4 from the right. I'm going to do the right side first. So the limit as x approaches 4 from the right of f of x, you take the function that's to the right of 4, which is 6 plus x, or 6 minus x, and you plug in 4 to get 2. Then we're going to do the limit as x approaches 4 from the left of f of x, and that's the negative 2 to 4 section, which is the cube root of 2x. And when you plug in 4, we're going to get the cube root of 8, which of course is 2. Since the right side equals the left side, we can say that the limit as x approaches 4 exists. Now we're going to do f of 4. It's x equals 4 for the cube root of 2x part, so we're going to have the cube root of 2 times 4, which is the cube root of 8, which is 2. And finally, for the third section of the definition, the limit equals the actual point equals 2. Therefore, f is continuous at x equals 4. Part A was worth a lot of points. You got 1 point for showing the right-handed limit, 1 point for showing the left-handed limit, and 1 point for showing that the left-handed limit and the right-handed limit were the same, or were this part. 1 point for doing f of 4, and 1 point for having the conclusion that f of x is continuous at x equals 4. With one small correction, since the right side limit equals the left side limit, then the actual limit equals 2, and that's worth a point. Okay. To get the average rate of change, you need the average rate of change formula, which is f of b minus f of a over b minus a. So if you plug in 0.004 for the first one, and then f of 0 for the second one, over 0.004 minus 0, you're going to get this, which equals 50. Part B was only worth 1 point. For part C, instantaneous rate of change is really the derivative at x equals 0. So, definition of a derivative at x equals 0 is taking the limit of the function minus the function at the x value and over x minus 0, and when you plug in zeros, those will go away, and then I separated the cube root of 2 and the cube root of x, and then I changed my exponents to be fractional, and then I subtracted my exponents, and if you plug in a 0 into this, that's undefined, so it does not exist. So therefore, there is no instantaneous rate of change at x equals 0 because the limit as x approaches 0 of f of x does not exist. The limit does not exist. This was worth a couple of points. You got 1 point for saying the limit does not exist, 1 point for using the definition of the derivative, and another point for basically simplifying that definition to a usable form. So either this one or this one. And that is the third and last question on the Limits AP Packet.